Right, so here's a quick clip on the required practical for specific heat capacity. So I'm just going to go a quick run through what specific heat capacity is. So, specific heat capacity is the energy needed to raise the temperature of 1 kilogram of a substance by 1 degrees C. So we can raise the temperature of any substance in multiple ways. Using a Bunsen burner supplies energy to it. Putting it out in the sun supplies energy to it. Different substances require different amounts of energy, so they take different amounts of time to raise their temperature. So, for example, we've got aluminium and wood out in the sun. After 5 minutes, aluminium has raised in temperature by 23 degrees. Wood has only raised in temperature by 12. So what we say that is aluminium has a low specific heat capacity, does not require much energy, or not much energy is needed to raise its temperature, so temperature increases quickly. Whereas wood needs more energy to raise its temperature because it's been in the sun for the same amount of time, but it's only increased by 12 degrees. So we say wood has a high specific heat capacity. A lot of energy is needed to raise its temperature, so temperature increases slowly. Now, there is an equation for specific heat capacity. Now, that has been rearranged for you. Okay, and it's just there. You can get it on your equation sheet. If you get this required practical that you need to describe in your exam, you'll have to rearrange it like that. But you'll have it as energy equals mass times specific heat capacity times temperature change on the equation sheet. Right, so let's run through the method. So what we've got is an aluminium block just here, okay? And it could be anything. It could be liquid that we need to work out specific heat capacity of. It could be copper, but we just do everything in exactly the same way. So we've got our material of aluminium just here. We've got our joule meter, which measures the energy going into the heater, which then transfers into the block. Then we've got a power supply that supplies the energy. We've got a hole in our block, which puts the immersion heater in, and we've got a thermometer that fits into another hole in the block. Now we fill both of these with water and then put the heater and the thermometer in because it allows the thermal energy to transfer to the block much more efficiently. So the first thing we do is measure the mass of the aluminium block using a mass balance. Okay, really important because we need mass just here. So we're using the equation to help us to structure our answer. So we've measured the mass, we've got that one ticked off. Connected immersion heater, joule meter, and power supply in series. So in series just means one thing after another, like a chain. So you can see the power supply is connected to the immersion heater. The immersion heater is connected to the joule meter, and it connects back to the power supply. So in one loop, that's all series means. Put water in the holes of aluminium block for the reasons I've said before. Place thermometer and immersion heater into the holes in the aluminium block. Wrap insulation around the aluminium block. The insulation is to stop the thermal energy escaping the block. We're measuring how much thermal energy goes into the block. We don't want that thermal energy to escape into the atmosphere, so we insulate it to reduce that happening. Turn on the power supply and time for 5 minutes using a stopwatch. Remember, it's always important to state the equipment you're using. So every time I'm stating the equipment, I've stated the stopwatch, I've stated the mass balance, immersion heater, joule meter, etc. Record the number of joules from the joule meter and measure the temperature using a thermometer. Use the equation, which we've got down here, to calculate the specific heat capacity. And repeat twice more and calculate the mean. It's as simple as that. Okay, that's it. You'll get your full marks if you mention all that. Sometimes they add extra stuff. Is why is there insulation around it? Okay, so you'll just say something along the lines of insulation stops the thermal energy from escaping. The results will be less accurate because of the energy being that you've measured by the joule meter being transferred to the atmosphere. Okay, you might be asked about the water. That helps the thermal energy to be transferred to the block. Thank you. That's it for that one.